As already mentioned, I'm Katharina and I'm working with Michael Kegmeier on the project GAPCo. Unfortunately, Michael cannot be here, so I will present the project by myself. And GAPCo stands for Game-Based Assessment of Physics Competencies. Yes, and the project is an intelligent and adaptive learning game in the field of physics. And the focus of the project is the diagnosis and the possible intervention of the misconceptions in force emotions. And in addition, the temporal progressions of learning, including forgetting processes, and should be identified and analyzed. In this way, the game provides students with personalized learning experiments. So finally, before presenting the project by itself, I would like to give you some background information about the project with the focus of adaptive educational systems. So serious games offer a possibility of game-based learning by integrating adaptive educational technologies without the need of human teachers. So therefore, it is possible for anyone, regardless of the educational setting, to learn knowledge of their own. And adaptive methods allows open learning, which still supports and guides the learner in the learning process. This can be done, for example, by providing adequate feedback that informs the learner of repeated errors or intervenes when learning progress is unsatisfactory. So by adapting to the needs and the game behavior, adapting learning games enable to motivate the learners. So in addition, the game can adapt the preference and needs of the learner or the gamer. So it takes a theoretical and a technology approach that allows the game to assess the cognitive states, for example, the skills or the motivation levels, then the learning progress, the potential skill gaps, or the unfocused problem-solving strategies. So in short, the very basis of personalization and adaptation is sound assessment. In other words, a game's capabilities of understanding the goals, the requirements, the needs, fluctuating affective states, and the learning progress of individual learners. So assessment must occur unobtrusively without breaking immersions or limiting the degrees of freedom. So over the past years, Michael and his colleagues delivered a framework based the knowledge-based theory and for an adapted, non-invasive in-game assessment of learning processes and affective states named the micro-learning spaces. So this is also where our project connects. So short of the theoretical underpinning, because the adaptation approach builds to the foundation of competency-based knowledge-based theory. It's called short the CBKST, and it is advancement to the micro-adaptivity and the micro-learning spaces. So we hope that the approach provides us with all the learners' actions with the game environment regarding existing and missing competences or skills. So in this context, CBKST is a theoretical framework for modeling and analyzing the knowledge structure and learning progress of individual each domain. So CBKST takes the view that the knowledge can be represented as a framework of interrelated concepts or skills, and It is also a framework that models and evaluates knowledge of the learning progresses. In this model represents knowledge as a hierarchical structure of interrelated concepts or skills, and in addition it allows the states of knowledge of learners to be measured and recorded to apply personalized learning. So to realize this educational adaptation and correctly interpret all the actions of learner within the game environment, we will integrate, as I mentioned, the microlearning approach into the physics learning game. So it's called the microlearning spaces, short MLS. And this approach aims to identify and process exciting and missing competences or skills to help the learners without the human support. And from this integration with game-based education, we hope to obtain a range of raw data in measurement, assessment, and evaluation. So from this data, we hope to gain insights to general effectiveness of the game. And in addition, we hope to gain information and knowledge about the students through gaming. The data hopefully shows us possible learning path and learning difficulties, strengthen our theoretical underpinning at the end of the project. And also we hope to contribute to educational fairness through the provision and use of our educational game. So based on the data obtained, it is important that we get a picture of what kind of adaptation we needed and the different educational levels. So I would like to discuss this question also with you at the end of the presentation. My next point of the presentation is the digitalization and the learning games, and the question why an adaptive learning game in physics. So one of the main reasons is that digitalization is changing the education, and this is leading to our trend of more competency orientation, formative and contextual assessment, and evidence-based personalization of learning. So games have also the benefits on focusing on learners' competence in a natural way, and these include clear goals and rules, relevant learning context, a compelling story and competition, and also moments of surprise and a rich and engaging learning environment. Also based on these facts, games have a very high popularity and regulate the game motivation of everyone. Also, they lead to successful and effective learning. Also, digital games are already an essential part of our digital world and a functional part of human learning. So because of the long use of games in the learning process, it's obvious to use digital learning games in the digital world to support learning processes. Here, digital games offer a variety of possibilities to adapt and design virtual games, for example, to illustrate the learning content. So this research state is where the project idea for physics came from. The relation to physics comes from the fact that STEAM domains is a perfect base for exciting and attractive gaming environment. And in addition, computer games are very usable in the STEAM disciplines and have used a lot. STEAM disciplines also have the benefit that learning content can be easily explored, and in a very experimental and exciting task can be designed. So based on our project, the physics domain tends to have well-defined domain structures. Misconceptions are quite common and well-researched. And physics naturally contains game-able tasks. So one of these aspects are particularly focused this project are the misconceptions. So I want to give you our prominent misconceptions. For example, the NASA famous 1972, the hammer and feather experiment. So students often hold the misconceptions that heavier objects are more affected by gravity and fall faster even in the vacuum. So students also tend to overestimate the effects of air resistance. So in addition, physics represents an unpopular discipline for students. This leads to the question if a stronger adaptivity is necessary in the physics domain, and also how strong is the impact of the game design on the learner's motivation to play. So based on this, I would like to raise another point of discussion, namely what in your view is necessary and excited from the design implementation aspects for the physics domain, and what design elements do you think should be integrated and considered in our physics game, which is set in the lower secondary level, so aged between the age 12 and 16. So, but we can do it later on the presentation. So I come short to the project aims. As already mentioned, the main goal of our project is to deliver the micro-learning space. Based on the knowledge-based theory, this approach is used for non-intensive assessment of learning processes and affected states in games. The first object is to model misconceptions and forgetting processes that have not been investigated conclusively in the past, and the process we aim to produce a solid, valid, and up-to-date psychometric assessment and approach framework for serious games. And the second one is to evaluate the MLS approach experimentally. So for this purpose, we use the existing game physics playground. In addition, a specific competence and assessment model in force and motion, including misconception and forgetting process, will be designed and implemented. So my last chart is some details and hopefully the success of our serious games. Yes, to reach our goals, we need to provide a learning experience in the game that is intrinsically motivated and useful. Also here, it is important that we create personalized learning experiments. The game should provide proper support and feedback to learners without the need of human teachers to intervene. And also, we want to minimize the factors such as boredom or overwhelming learners while they are learning or playing. So it is important for us that the game adapts automatically and in real time to the characteristics, needs, strengths, and weaknesses of the learners. And to enable effectiveness, personalization, and adaptation, valid assessment is required. So this means to understand the capabilities in the game, the goals, the needs, the changing affective states, and the learning progress of each learner. And at the same time, the assessment must be discrete without interrupting the immersion and learning possibilities of the game. So, yeah, this so was the last chart of my presentation, and with the last one, I want to start the questions for you. Yeah, I don't know. Maybe you can read the questions, and maybe someone can want to say something about that. Thank you.